Hi guys, this is Professor Hobbs here, and we are going to start working on some dosage calculation problems today. And we're going to use dimensional analysis to solve these dosage calculation problems. So what I'm going to do is I'm going to present you with the basic information that you need to have in order to solve these problems. I know you guys probably have already memorized all of this throughout your courses, your different courses here, but it's always nice to have that refresher. So I'm going to present that and remind you about those different pieces of information that you're going to need in order to solve these problems. Um, I'm going to remind you how to read a drug label and drug orders. And then we're going to start looking at the basics on using dimensional analysis to solve problems. Okay, so what we'll do is we'll break it down into, I call them rules, steps, whatever you want to call them. I have a very specific way of solving these problems using dimensional analysis. And I do it the same way without fail, regardless of the type of problem that it is. So what I'm going to do is break down how I do that with you and show you how to do that, show you how to pick apart the problems and figure out the information that you need in order to solve the problems. Okay, and then what we'll do from there is we'll start working on different types of problems. We'll start with some daily versus single dose type problems, and then we'll move into the different types: oral, parenteral, IV, dosage by weight, and then safe dosage. Okay, so those are the different categories that we're going to cover. And I'll break those down into smaller little videos. So this video is just going to cover the basics, and then we're going to cover dosage, daily dosage versus single dosage problems, just to help you to try to figure out when you're solving these problems, whether you need to figure it out for an entire day's worth of dose or either just one dosage. Okay, so we'll cover all of that. So the first thing I'm going to do is stop the video because it kind of covers a whole bunch of my screen and it's distracting. So I'm going to go ahead and stop the video, and then we'll get started on just again going through some of this basic information for you. Okay, so we'll start by looking at household measurements versus the metric system. So household measurements in the United States, most of the time we use household measurements to indicate length, weight, or volume. Okay, so that's like inches, tablespoons, cups, ounces, pounds, things like that. Okay, but in the medical profession, the measurements are metric. Okay, so the units of measure for metric is meters, grams, and liters. Okay, meters being length, gram being weight, and liters being volume. Okay, so because the medical profession uses the metric system to indicate the dosage of a medication or the volume of a medication, or even in a few cases, the length of the medication, we have to learn how to convert some of our household measurements into that metric system. Okay, so you'll use this a lot for weight. If the patient's weight is indicated in pounds and ounces, then we would have to convert that to kilograms. And also for intake and output, when you're monitoring a patient's intake and output, a lot of times the volume of the fluids that they're taking in are measured in like a cup of coffee or a pint of milk or something like that. So you would have to convert that measurement into milliliters in order to document and indicate what they have taken in. Okay, so that's the reason for, or the rationale behind um, learning to convert. Okay, so on the left-hand side of the screen, you can see dosage calculation conversions. So those are the ones the very common ones, the ones you're most likely to see on the NCLEX. Okay, and I know you guys have probably already committed these to memory as you've gone through this program, but again, just as a refresher, they're right here. These again are the most common um, uh, conversions that you would need to know, okay? And then on the right-hand side, I've given you just a refresher on the different abbreviations, frequencies, and routes. When you are presented with a problem on the NCLEX, you are going to be presented with problems that use this terminology or these different types of terminology. So you want to make sure that you are familiar with it, especially the dosing frequencies, because a lot of times that'll trip you up when you're trying to solve problems if you don't know that TID is 3 times a day, or QID is 4 times a day, or QHS is bedtime. Okay, so just make sure that you commit those to memory as well if you haven't already. Okay. All right, so now let's just do a quick refresher on the drug labels. Okay, so one of the things that trips a lot of students up on drug labels is everybody learns, well, it's a generic name if it's not capitalized, and it's a brand name or a trade name if it is capitalized. And while that is true in some situations, on the labels, a lot of times the generic name is the first word in a sentence, or they just capitalize everything on the entire label. So it's not really helpful for you when you're trying to figure out what's generic versus what is a brand or trade name. So if you look on this label here, you can see it says right here, Aritab, and then you see a little R with a circle around it, and I'll make it bigger right here. Okay, that means that it is a trademarked or a registered brand name. Okay, so anytime you get confused about what's generic and what's your trade name, you can look for that R with the circle. Sometimes it might be a TM with a circle as well. I don't know that I've seen that recently, but it's not outside of the realm of possibility. So, but anytime you see that R or TM with a circle around it, that's going to indicate to you that that is a registered brand name. It means the brand has paid for that name and nobody else can use it. Okay. So in this label example here, Aritabs are going to be your brand or trade name, and erythromycin, which is down here, is going to be your generic. Okay. Other things that you need to note when you're looking at the labels is you need to be able to find the dosage. Okay, so sometimes it'll say, in this case, 333 milligrams is your dosage. So sometimes it'll say 333 milligrams per tablet. Okay, sometimes it'll just say, like this one does, 333 milligrams. And then you'll see the tablets are up here. It tells you there's 100 tablets. Okay, so when that happens, sometimes you can look over to the side over here. Okay, and you can read some of the small print. And in this label here, it says right about here, each tablet contains erythromycin 333 milligrams. Okay, so make sure, if you're not 100% certain what the dosage strength is for the medication, feel free to read all the small print, because a lot of times there's some really good information in that small print that will help guide you to make sure that you are putting the correct information into your problem. So for this one, if you were using this label to solve a math problem and it gave you this label and said, this is what you have available in your drug cart, you would have 333 milligrams over 1 tablet. Okay, that would be what your what you would indicate for that. Okay, other information, the lot number and expiration, you can see those are usually clearly labeled. The manufacturer over here, the drug form, that's important. You see that up here where it says tablets, and it also says right here, delayed release enteric coated tablets. Okay, so remember, when it's enteric coated, you can't split it because you destroy that enteric coating. You can't crush it or split it or anything like that. Okay, So those are just some of the things that you'll see on labels. So I'm going to pause this for just a second and see if I can make it so that my name does not pop up every time I click on something. So hold on one second for me. Okay, so hopefully that fixed that. So let's move on and let's just look at a couple of more labels, and I'll just point out a couple of other things that you might see on these labels. Okay, so this is a label for amoxil, which is amoxicillin, and this is a liquid. It's an oral suspension. It's actually a powder, I'm sorry, until it has had some liquid added to it, okay? So on this one, you see up here your dosage. Yay, it worked. Your 200 milligrams per 5 milliliters, that would be your dosage. Again, you see the little R with a circle right here. So that indicates that's the brand name, and then your generic is right beneath it, amoxicillin. Okay, volume right here, 50 milliliters when reconstituted. So that means that bottle, when we add the appropriate liquid to the bottle, has 50 milliliters of solution in it. Okay, so, and then off to the side here, you can see directions for mixing. That's very important. We want to make sure that we follow the directions for mixing. And it also tells you, if you read further down, each 5 milliliters will contain amoxicillin equivalent to 200 milligrams. Okay, so basically it's saying exactly what you read up here. But remember, I told you sometimes you get the information in a little small print as well. Okay, so that's another example. And then, let's see, I wanted to show you, oops, clear that. I wanted to show you some controlled substance type labels as well. So remember, controlled substances fall into they fall into different categories or schedules based on their potential for abuse, okay? So in order to determine what schedule the medications are, you're gonna look for this right here. Okay, it's a C with Roman numerals inside. So this would be a category 4 scheduled drug, okay? It's going to be, or it's going to fall under schedule 4, I'm sorry, of the controlled substance schedule, okay? So everything else, if you look on here, this says phenobarbital tablets. You notice that there's no R with a circle after it. So this medication doesn't even have a brand name listed. It is simply a generic phenobarbital medication. Okay. Let's see. That was it for that one. Okay, and then this one, I just wanted to show you that you want to make certain when you're pulling drugs out of the cart or choosing the correct label. If you are presented with labels on the NCLEX, you want to make sure that you're reading the label completely and thoroughly, because you can see here these medications both start with PERCO. Okay, the only difference is the last 3 letters. However, they are different medications. The one on the left is Percocet, which has acetaminophen in it. And the one on the right is Percodan, which has aspirin in it. They both have oxycodone, but then they also have an adjuvant medication to help make them more effective. But you need to make sure you're giving the correct one. So always, always do your 3 checks, which we'll talk about in a minute, and make sure that you're reading these labels thoroughly and completely before you dispense the medication. Okay, you can also see here, these are controlled drugs. You see these are Schedule 2 right here. Okay, they have the C with the 2 in it. Okay. All right, so let's review the basic principles in medication administration. And I know you guys have probably gone over this ad nauseum, but 3 checks and 7 rights. The NCLEX will assess your knowledge and understanding of the 3 checks and 7 rights, okay? So definitely make sure that you have committed this to memory and you understand, okay? So the 3 checks basically refer to you checking the medication against the order 3 times. Okay, so that means when you pull the container out of the cart, you're going to check the container and make sure that the dose and the amount and the name of the medication matches what's on your MAR or your order. Okay, then you're going to check again as you're actually removing the medication from the container. And then you'll finally check one last time before you replace the container back into your cart. Okay, that will help you to prevent you from accidentally dispensing to the patient the wrong medication. Okay. And then in addition, you want to make sure that you're following the 7 rights for every medication that you administer. And that is to make sure that you're giving it to the right patient, that you're giving the right dose, the right drug, you're giving it via the right route at the right time and the right frequency, and that you always document what you have given, usually on the MAR. Just make sure that, again, if you don't document, it didn't happen. So if you gave the med but didn't document that you gave it, it's like you didn't give it. Okay, and that also opens up the likelihood that someone may come behind you and give it thinking that you didn't, and that patient could be overdosed. Okay. All right. So this slide discusses the essentials of a medication order. Okay, so these are orders written by, this says physician, but we all know we have other prescribing practitioners nowadays that can write orders as well. So the drug order has these 7 essential parts, and we need to make sure that when we receive an order from a prescribing practitioner, that we are ensuring that it has all of these components. If it doesn't, we need to contact the prescriber and have that fixed. Okay, so it should include the patient's full name, the date and time that the order was received or written, the name of the drug, the dosage of the drug, the route of administration of that drug, the time and frequency of administration, and the signature of the physician or prescribing practitioner. Okay. So if you receive a verbal order or a telephone order from a prescriber, they have 24 hours to sign that, but you will sign it in lieu of them signing, noting that you took it as a verbal or telephone order. And then the physician will come back again within 24 hours and have to sign that order. Okay. So here's an example just for you to kind of see what we're talking about. We've got the patient's name. Okay, we've got the date and the time that the order was written. We have the actual medications listed out. And within each medication, you have the name of the medication, the dosage, the route, and the frequency. Okay, and then you see it's just typed in here the doctor's signature, but of course we're gonna go under the understanding that that's signed. Okay, so this is to let you know that in a facility you may have 3, 4, 5, 10 drugs that are written on your physician's order. Okay, it's not like a home medication where we have 1 prescription per medication. Okay. So we want to make sure when we're transcribing or moving these medications to the MAR that we're including all of these medications and double checking to make sure that they are correct. Okay. All right, so now let's look at a typical dosage calculation problem. These are ones that you are likely to see on the NCLEX. And in order to solve them, you need to know what you're looking at, right? That makes sense. You need to understand what it is it's asking you to do. So in this case, we're just going to kind of pick apart this, this problem, okay? So we're going to look at the problem first. And it says the physician has ordered Roxanol oral solution, 30 milligrams, PO, Q4 hours, PRN pain. Available is Roxanol oral solution, 20 milligrams per 5 milliliters. How many milliliters will you administer per dose? So let's break it down. We know we need, when we're solving these problems, most of the time, and I'll tell you later on what the exceptions are, but most of the time we need the order. We need to know what the physician or practitioner has ordered. Okay, so in this case, the practitioner has ordered Roxanol oral solution 30 milligrams, and they've ordered it PO, which means by mouth, Q4 hours, which means every 4 hours, and then PRN pain, which means that it is the nurse's discretion to give this medication as needed if the patient is in pain. Okay. So your order, if I was to write it over here, would be 30 milligrams per dose. Okay. So where did I get the per dose? Because it doesn't say that, right? It says Roxanol oral solution 30 milligrams PO Q4 hours. So when I see Q4 hours, that tells me that this patient is receiving 30 milligrams every 4 hours as needed. Okay, so that means every dose they receive, they're receiving 30 milligrams. Okay, it doesn't say 30 milligrams daily divided into doses. It says 30 milligrams Q4 hours. So I'm going to write that as 30 milligrams per dose. Okay, and this will make sense when we start solving these problems. This will help you with your daily versus dose type of problems. Okay. So the other piece of information we almost always are going to need when we solve these problems is what we have available or what our supply is. So in this question, it says available is Roxanol oral solution, 20 milligrams per 5 milliliters. So that is our supply. So 20 milligrams per 5 milliliters. Okay. So the third piece of information that I will try to get out of this problem is the dosing schedule. So what I mean by that is I want to compare the dosing schedule of the order against what the question is asking me. Okay, I want to make sure it matches. If it doesn't match, that tells me that I'm going to have to plug in a little bit more information when I'm solving this problem. So let's start by looking at the order. The order is per dose, right? We just wrote it right up here, right? Okay, so let's compare that to what the question is asking. The question says, how many milliliters will you administer per dose? So the question is asking us per dose as well. So the dosing schedules match. Okay, and again, what I mean by that is the order is written per dose and the question is asking me to calculate an amount per dose. Okay, so it matches. So, and again, this will make more sense once we start solving the problem, but I always like to look at my problem first before I start solving it to just kind of get a feel for the information that I'm going to need in order to solve it. Okay. All right, so let's look at another one. Okay, and this question is a dosage by weight problem. Okay, these problems ask us to calculate a dosage amount based on the weight of the patient. Okay, so this order reads, the physician has ordered amoxicillin oral suspension, 30 milligrams per kilogram per day in divided doses every 8 hours for a child who weighs 39 pounds. Available is amoxicillin oral suspension, 125 milligrams per 5 milliliters. How many milliliters will you administer per dose? Okay, so again, let's look for the order. Okay, the order is amoxicillin oral suspension, 30 milligrams per kilogram per day. Okay, so I'm going to write 30 milligrams per kilogram per day. Okay, that means every day this child is going to receive a total amount equal to 30 milligrams per kilogram of weight. Okay. We also need the supply. And it says in the problem, available is amoxicillin oral suspension, 125 milligrams per 5 milliliters. Okay, so that's our supply. We need the weight of the patient. That makes sense, right? If we're going to calculate a dosage based on the weight of the patient, we need the weight of the patient. So the patient weighs 39 pounds. Okay, and then the dosing schedule. Again, we want to compare. If it doesn't match, we know we have to do a little bit extra calculations when we solve this problem. So let's look at the order. And the order is written 30 milligrams per kilogram per day. Okay. And then let's look at what the question is asking. The question is asking, how many milliliters will you administer per dose? Okay. So it does not match. So we know when we solve this problem, we are going to have to make sure that we include a conversion that converts day to dose. Okay. And of course, I'll show you what I'm talking about. Okay. So these are just to, again, to illustrate to you the different pieces of information that you're going to need and how to pull them out of the problem. Because when we learn how to do these problems, we're going to do it in a very specific order, and we're going to pull this information out as we need it, okay? All right, whoops. All right, so now let's look at the rules. And again, these are the rules that you're going to follow for every single problem that you solve. These rules do not change regardless of whether you're solving a problem for drops per minute, milliliters per hour, tablets, capsules, milliliters, milligrams, time, hours, days, it doesn't matter. You're going to solve the problems the same way every single time. And you need to follow this order. Okay. And why is that helpful? Because if you follow these rules in the order that I'm going to present them to you, the problem will essentially solve itself. It will tell you what you need to plug in next to the problem. It will tell you if you're missing information. It will tell you if you try to put information in there that doesn't belong. Okay, it's a really great method for solving, especially for people who have math anxiety, because it guides you. But you have to do it in the correct order in order for that to work, okay? So I'm just going to read these rules. They're not going to make a whole lot of sense unless you've had dimensional analysis with me before. So just we're going to read the rules again so that they're on the screen for you to refer back to. And then we'll solve some problems using these rules so that we are able to we're able to see how to do these problems, okay? So rule one is always going to be to determine what unit of measure your answer will be in. And that's usually the last sentence or the second to last sentence of the problem. And usually it's phrased like, how many tablets will you give per dose? How many milliliters will you administer per day? You know, how many milligrams of this medication will you administer? Okay. So it's going to, your first step is going to be to determine what that unit of measure is going to be. Okay, your second step is to determine what information you will need to solve the problem. So we just covered the anatomy of dosage problems a minute ago. And then when we hit each specific type of problem, I'll discuss further the types of information that you're going to need to pull out of that problem, okay? So you're going to take that information, you're going to build a little box, and you're going to put that information in your box, okay? So step 3 is you're going to then take that information that's in your box and you're going to build a problem with that information. And you're going to plug that information in starting with the unit of measure that you determined in step 1. So if you're looking for tablets, your first part of your problem is going to be tablets. Okay, and then you're going to continue to plug information in, alternating the units of measure in the denominator with the units of measure in the next numerator. And the purpose of that is so that we can cancel out all of those extra units of measure. That's what our goal is. We want to cancel all units of measure out so that the only thing left is what we are looking for. Okay, so all of this goes back to step one. You have to know what unit of measure your answer will be in order to do this method. Okay, so step four, you're going to cancel all units of measure that are left in the, or all units of measure that are in the numerator and the denominator. And you should be left with the unit of measure that your answer will be in. Once you get to that point, then you can multiply straight across, then divide. Okay, so again, I recognize it's difficult to kind of visualize what we're talking about without actually working them out. Don't stress, I will work several out for you, but I did want you to be able to have these rules to refer back to. Okay. All right, now remember you can flip your information as long as you keep it together. So what do I mean by that? Well, in dimensional analysis, everything that you're going to use is written as it's written as a fraction. It's not really a fraction, but it's written as what you would consider to be a fraction. Okay, it looks like a fraction with a numerator and a denominator. Okay, so my example here, if you in the problem it says that you have 5 milligram tablets, you're going to write that as 5 milligrams over one tablet, or you can flip it and write it as one tablet over 5 milligrams. Okay, can use it either way. And I know that it's probably not apparent to you right now why you would need to flip it, but it will be. Okay, so just remember that you can. All right, you can and should do all conversions within the single dimensional analysis problem. So what do I mean by that? You don't want to round, or I'm sorry, you don't want to work out these conversions separately and then plug them into the problem, because that increases your likelihood for making an error. And also, if you round some of these conversions and then plug them into the problem, you're going to end up getting the answer incorrect, and you could end up over or underdosing the patient. Okay, so you're just going to write these conversions as fractions, quote unquote fractions, and plug them in. So here's an example of what I'm talking about. 1 liter is equal to 1,000 milliliters is one of those conversions that was included a couple of slides ago, right? That you need to know. So you're going to write that as 1 liter over 1,000 milliliters. Okay, another conversion that's important that you know, 1 kilogram is equal to 2.2 pounds. And you're going to write that as 1 kilogram over 2.2 pounds. And you can flip these. You can flip any and everything that you're using in these problems, okay? All right, the next rule, don't round until the end of the problem. Okay, and that when you're using dimensional analysis, that's usually not an issue, because you just do, once you set your problem up, you just multiply straight across, divide, and then you round, okay? But just make sure that if you are doing conversions outside of the problem, which I strongly advise you not to do, that you are not rounding, okay? Know your rounding rules in places. So your questions are going to tell you how to round. They're going to say round to the 10th place, round to the 100th place, round to the whole number. You need to know what that means. Okay. And you need to know your conversions, which we discussed in previous slides. So make sure that you have committed those to memory. Okay. All right, so this is a very basic problem, and I know I just told you don't do kilograms outside of the problem, but in this case, this problem is simply converting the weight of a patient from pounds and ounces to kilograms. Okay, so sometimes you will get problems that are simply that. So you do need to know how to do that. But if the problem is more than just converting from pounds to kilograms, obviously you don't want to well, yeah, then you don't want to do it separately. Okay. But let's do this problem. These are a little bit more tricky because ounces have to be converted to pounds before you can solve this problem. So one mistake that a lot of students make is that they think that 11 pounds, 4 ounces can be written as 11.4 pounds. And that's not the case. Okay. So you're going to get the answer wrong if you don't do that correctly. So let's look at this problem and we'll solve it, of course, using dimensional analysis. Okay. A nurse is caring for an infant who weighs 11 pounds, 4 ounces. What is the infant's weight in kilograms? Round the answer to the nearest hundredth. Okay. So step one, what are we looking for? Okay. So we're looking for kilograms. All right. But we know, because we had Miss Hobbs for dosage calculation and she told us this, you have to convert these ounces to pounds first before you can determine the infant's weight in kilograms. Now, if it just had said the infant weighs 11 pounds, you can go ahead and convert straight to kilograms. But those 4 ounces have to be converted to pounds first. Okay, so how do we do that? So I'm going to show you how to do it using dimensional analysis. There's maybe an extra step when you do it this way, but again, it teaches you how to use dimensional analysis. So the first thing we need to do is convert 4 ounces to pounds. So we're looking for pounds. In our box, we don't need to convert the 11 to pounds because it's already pounds. So the only thing we need to convert is the 4 ounces. We also need our conversion from ounces to pounds, right? That was on that first page. So we know that 1 pound is equal to 16 ounces. So you can see here, just like I showed you guys on the previous slide, I'm always going to write everything as a fraction. Okay, so that was step 2, building my box. So step 3 is to start plugging into my problem. And I'm going to start with what I'm looking for. Okay, so pounds is what I'm looking for. So I'm going to come up to my box and find pounds in my box. All right, so I have 1 pound over 16 ounces. So I'm going to plug that in. Okay. Now, what do I do next? Well, I'm going to look at the unit of measure in the denominator here, which is ounces, 16 ounces, and I'm going to match that unit of measure in the numerator of the next part of my problem. So I need ounces. So I come up to my box and I find ounces. Okay. Once I've used everything in my box, I need to cancel like units of measure and see what I'm left with. Don't skip this step. This step will tell you whether or not you have completed setting your problem up. Okay, that's another issue that I see a lot of students, another mistake I see a lot of students making, and it ends up creating a problem for them because then they don't set the problem up correctly. So always cancel like units of measure. So I had ounces in the numerator and ounces in the denominator, so I was able to cancel. And the only unit of measure that I'm left with is pounds, which matches what I'm looking for. Okay, since it matches what I'm looking for, that is my indicator that I am done setting this problem up. Now all I need to do is multiply straight across. 1 times 4 is 4. 16 times 1 is 16. And then divide. 4 by 16 is 0.25. And my unit of measure is located right here, is pounds. Okay, so that's step 1 of this problem, because I had to convert, again, the ounces to pounds. So now I can actually convert the infant's weight to kilograms. So I'm going to do the exact same type of problem, but now I have the infant's weight in kilograms. So it is 11.25. I'm sorry, the infant's weight in pounds. I have the infant's weight in pounds, 11.25 pounds. Okay. And I need my conversion for kilograms to pounds. And that is 1 kilogram is equal to 2.2 pounds. So I'm going to write that as 1 kilogram over 2.2 pounds. Okay, so that's step 2. Step 3 is to start building my problem, starting with what I'm looking for. So I'm looking for kilograms, so kilograms needs to be the first thing I plug into my problem. So I come up to my box and I find kilograms. Okay. So how do I know what to put next? Well, I have pounds on the bottom here in the denominator. So I need pounds in the numerator. So I come up to my box and I have 11.25 pounds. Okay, once I've crossed out everything in my box, then I'm going to cancel like units of measure. So the pounds are going to get canceled. And I'm left with kilograms, which matches what I'm looking for. So that means that I am done setting my problem up and I can now do my math straight across. 1 times 11.25 is 11.25. 2.2 times 1 is 2.2. 11.25 divided by 2.2 is 5.11 kilograms. Okay, and always check your rounding rules. So this problem says round your answer to the nearest hundredth. So it is rounded to the nearest hundredth. So I don't have to do anything else. Okay. So that is how to convert pounds to kilograms when you have ounces as well. So let's do another one. Okay. This one is essentially the same, it's just got a different weight. So this infant weighs 10 pounds, 4 ounces, and it's asking us to calculate the infant's weight in kilograms. And this one says round the answer to the nearest tenth. So remember, always read your rounding rules. Okay, so we're going to do the same thing. We're going to start by converting those ounces to pounds. So it's 4 ounces. And then we know that 1 pound, 16 ounces, right? Okay, and then we're going to plug in our problem starting with pounds because that's what we're looking for. So we're going to plug in 1 pound over 16 ounces. Okay, we have ounces on the bottom. We need ounces on the top. So we're going to plug in our 4 ounces. Once I've used everything in my box, cancel out like unit of measure, and I'm left with pounds, which is what I'm looking for. So I can do my math straight across. 1 times 4 is 4. 16 times 1 is 16. Okay, so 0.25 pounds, same as the previous problem. Okay, now that I have converted those ounces to pounds, I can go ahead and do the problem, which is to convert the weight of the infant. So now it's 10 pounds, 10.25 pounds, right? Instead of 10 pounds, 4 ounces is what the infant weighs. And then, of course, we need our 1 kilogram over 2.2 pounds to convert. Okay, so we're going to plug it in, starting with kilograms, because that's what we're looking for. Okay, we have pounds on the bottom. We need pounds on the top. All right, I've used everything in my box. So I'm going to cancel pounds, which are like terms, and I'm left with kilograms, which matches what I'm looking for. So that tells me I can go ahead and do my math straight across. 1 times 10.25 is 10.25. 2.2 times 1 is 2.2. 10.25 divided by 2.2 is 4.65. And my rounding rule says round to the nearest tenth. So this answer is 4.7 kilograms. Okay. So I am aware that you can just divide. You don't have to go through all this trouble when you're converting pounds to kilograms. So if you're comfortable doing that, that's fine. Again, I like to do everything in dimensional analysis. It helps me to, again, develop that muscle memory and become more proficient. And B, I know the steps. I know I'm doing it correctly, so I'm not worried about accidentally doing something wrong and making a mistake. Okay? All right. So the last thing we're going to talk about on this section is daily versus single dosages. So this is very important that you get in the habit of setting your problems up correctly so that you don't get a problem wrong simply because you didn't calculate for the either dose or day schedule that it gave you. Okay? So if the question asks you how many blank, whether that's tablets, capsules, milliliters, whatever, how many blank will you administer per dose? You need to make sure the order is written per dose. And I've already illustrated to you in previous slides what I'm talking about. If the order is written per day, or either the problem asks you to calculate a daily dose, you are going to need to enter a conversion. And I have given you the conversions right here. Okay. So you are going to build in a conversion using the dosing schedule of the order. So if the order says to give every 12 hours or uses the term BID, you can use the conversion 1 day over 2 doses, because that means that in 1 day, this patient is receiving 2 doses of medication. Okay, if the order dosing schedule is every 8 hours or TID, you can use the conversion 1 day over 3 doses, because in one 24-hour period, this patient's going to receive 3 doses of medication. Okay, every 6 hours or QID is 1 day over 4 doses. That means in 1 day or 24-hour period, patient's going to receive 4 doses of medication. And then every 4 hours is 1 day over 6 doses. Okay, and you can flip these, just like all the other stuff we've been flipping or we are going to flip. You can flip these as well. Okay. So let's work on some of these problems and learn how to calculate them or how to set them up every single time this way so that we don't have issues with these daily dosing versus single dosing problems, okay? So we'll start with an order for cephalosporin oral suspension, 225 milligrams POBID. On hand is cephalosporin suspension, 375 milligrams per 5 milliliters. How many milliliters will you administer per dose? Okay. So remember, before I even start with my rules, I always just check my dosing schedule just to see, just to kind of maybe remind myself in my brain, I might have to do something with this dosing schedule. So I look at the way the order is written, and it is written 225 milligrams POBID. That means twice a day, this patient's going to receive medication, 225 milligrams. Okay. So that is 225 milligrams per dose. So then I'm going to look at what the question asks me. Asks me how many milliliters will you administer per dose? So the question's asking me to solve per dose as well. So the dosing schedules match. Okay, so that means I don't need to enter one of my little dosing calculation or dosing schedule conversions that I just showed you. Okay, but the good thing is, even if you don't realize that or you forget it or you get flustered, just solve the problem the way I'm showing you to, and the problem will tell you if you need to add a conversion. Okay, that'll make sense as we work these problems. So let's work this problem using our steps, starting with step 1. What are we looking for? Okay, the question says, how many milliliters will you administer per dose? So we are looking for milliliters per dose. Okay, this is one of the things that I do differently. I am always going to include dose or day, and that is to prevent me from forgetting to take a last step to make sure that I'm given the correct dosing of medication, okay? So step 1, question says, how many milliliters will you administer per dose? So that's what I'm looking for, milliliters per dose. Okay, step 2 is to build my box. And in my box goes my order, which is 225 milligrams per dose. How do I know it's per dose? Right there, BID. Okay, so that goes back to your first couple of slides where you were looking at the dosing schedules. This means that every dose this patient receives will be 225 milligrams. Okay, I also need what I have available. The problem says available or on hand, I have cefaclor, 375 milligrams per 5 milliliters. So 375 milligrams per 5 milliliters is written as 375 milligrams over 5 milliliters. Okay. So I've put everything in my box. Now I'm going to start solving my problem. So I'm going to solve my problem starting with what I'm looking for, which is milliliters. Okay. Sorry about that. Right? Milliliters is what I'm looking for. So milliliters needs to be the very first thing that I plug into my problem. So I come up to my box and I look for milliliters. I have milliliters up there, right? I have 375 milligrams over 5 milliliters. Okay, but I want the milliliters on top because when I'm building my problem, the very first thing that I need to put in my problem in the numerator needs to match what I'm looking for. Whoops, that got very chunky. Okay, so this is where the flipping comes in. I am going to flip this so that the milliliters is on top. I'm not changing anything, I'm just flipping it. Okay, so I'm taking the 5 milliliters over 375 milligrams. All I did was flip the placement of the problem, or the placement of the numbers and the units of measure. Okay, then I'm going to cross it out because I used it. All right, so what do I need to plug in next? Remember, I want to match units of measure in the numerator and denominator so that I can cancel them out. So I have milligrams on the bottom here. So I need milligrams on the top, the next section of my problem. So I'm going to come up to my box and find milligrams. So I have 225 milligrams per dose. Okay, and then I'm going to cross it out because I used it. Okay, once I've crossed out everything in my box, I'm going to look at my problem and I'm going to cancel out all units of measure that I have in the numerator and the denominator. So in this problem here, it's going to be milligrams that are canceled out. Okay, now I'm going to look at what units of measure I have left in my problem. And they should match this right here. Should match what I'm looking for. That's the reason I wrote it over there. Okay, so what do I have left? I have milliliters over dose is what I have left. I have milliliters here, and I have dose here. So it matches what I'm looking for. So that means I'm done plugging things into my problem and I can go ahead and do my math. So I'm going to do my math straight across. 5 times 225 which equals 1125. 375 times 1 is 375. 1125 divided by 375 is 3. And my unit of measure is over here. Again, remember I wrote it at the very beginning of the problem. 3 milliliters per dose. Okay. All right, so let's do another one. They'll get easier the more you do. Okay, this is an order for ampicillin, 1200 milligrams IM daily to be divided into 3 doses. Available is ampicillin, 250 milligrams per milliliter. How many milliliters will you administer per dose? Round your answer to the nearest tenth. All right, so again, I always just kind of peek at the problem and see where I'm at. My order is for 1200 milligrams daily. Right? It says right here, daily. And then my problem is asking me to solve per dose. So they don't match. The dosing schedules don't match. So I just need to keep that in the back of my mind. But again, luckily, the problem will tell me when I need to add a conversion. So let's look at that. Let me show you what I mean. Step 1, what are we looking for? The question says, how many milliliters will you administer per dose? So we're looking for milliliters per dose. Okay, step 2 is to build our box. And in our box goes our order, which is 1200 milligrams per day. Okay, got that right here, 1200 milligrams daily. Okay, I also need what I have available, which is 250 milligrams per milliliter. All right, so I've built my box. Now I can start plugging into my problem. I'm going to start with what I'm looking for. I'm looking for milliliters, so milliliters is what I need to put in my problem first. So I come up to my box and find milliliters. I have milliliters, but it's in the denominator and I need for it to be in the numerator. So I'm going to flip it and I'm going to write it as milliliters over 250 milligrams. And then I'm going to cross it out. Okay, now I have milligrams on the bottom in the denominator, and I need milligrams on the top in the numerator of the next section. So I'm going to come up to my box and find milligrams. 1200 milligrams per day. Cross it out. Okay, I've used everything in my box. So once I use everything in my box, I'm going to cancel like units of measure and see what I'm left with. So in this case, I'm going to cancel milligrams. And I see that I'm left with milliliters per day, which does not match what I'm looking for. Here's where the problem tells you you're not done. This is why it's important that you cancel out and check. Okay, so the problem is telling me, hold on, you're not done because you're looking for milliliters per dose and you have milliliters per day. So I need to convert my day into dose. I need to get rid of this day here and change it into dose. So that's where the conversions that I showed you several slides back come in handy. I'm going to plug one of those conversions in here. But which one am I going to plug in? Well, I'm going to go back to my order. My order tells me what to do, right? The order's my boss. So I look at the order and the order says daily to be divided into 3 doses. So that means in one day, I'm going to give 3 doses of this medication. And I'm going to plug that in just like that. One day, over 3 doses. I made sure I put the day on the top because I want to cancel the day out. See, and now I can. So after I cancel day out, what am I left with? I'm left with milliliters per dose, which matches what I'm looking for. So now I'm done building my problem and I can do my math. Straight across. 1 times 1200 times 1 is 1200. 250 times 1 times 3 is 750. 1200 divided by 750 is 1.6. My rounding rule says to the nearest tenth, so I'm good there, 1.6. And then my unit of measure, again, over here, is milliliters per dose. Okay? So we're going to do 2 more. And then we're going to stop this video or finish off this video and give you a chance to practice. Okay? All right, let's look at another one. This order reads, you have received an order for terramycin 100 milligrams IM Q8 hours. Available is terramycin 50 milligrams per milliliter. How many milliliters will you administer per day? Okay, so let's look at our units or our dosing schedules really quickly. The orders for terramycin IM Q8 hours, 100 milligrams IM Q8 hours. That means every dose of terramycin or every 8 hours, the patient will receive 1 dose of 100 milligrams, right? Okay, so it's 100 milligrams per dose. And then the question says, how many milliliters will you administer per day? Per day. So it doesn't match, right? My order is per dose and the question's asking me per day. So let's keep that in the back of our minds. But again, remember, if we're following all of our rules, the problem will tell us when we need to add more information. Okay, so step 1, what are we looking for? We're looking for milliliters per day. Okay. Step 2, we need to build our box. In our box goes our order, which is 100 milligrams per dose. And we need what we have on hand. And on hand, we have 50 milligrams per milliliter. Okay, so now let's start plugging into our problem. That's step 3, starting with what we're looking for. So we're looking for milliliters, so we need to plug milliliters in first. So I come up to my box and find milliliters. I have it, it's just in the denominator and I want it in the numerator. So I'm going to flip it and I'm going to write it as milliliters over 50 milligrams. I'm going to cancel it out. Okay, now I have milligrams on the bottom in the denominator and I need milligrams on the top in the numerator. So I come up to my box and I have 100 milligrams over dose. Okay, I'm going to cancel that out. So now I've used everything in my box. That's my signal to go ahead and cancel like units of measure and see what I'm left with. So I'm going to cancel milligrams and I'm left with milliliters per dose, which does not match what I'm looking for. That means I need to add one more conversion. I need to change that dose to day, right? Because I'm looking for day, but my current answer is in dose. So how do I figure that out? I go and look at the problem, at the order, and it says Q8 hours. Okay, if you look at the cheat sheet I provided for you earlier, Q8 hours means that in one day, you're going to give 3 doses. So that's the conversion that I'm going to plug into my problem. Make sure you flip it. Okay. Remember, you're trying to cancel dose. So in order to cancel dose, dose needs to be on the top. So I'm going to flip it and write 3 doses over 1 day. Okay. That way I can cancel doses. And now I'm left with milliliters per day, which is what I'm looking for, or which matches what I'm looking for. Okay, so now I can do my math straight across. 1 times 100 times 3 is 300. 50 times 1 times 1 is 50. 300 divided by 50 is 6. And units of measure are milliliters per day. Okay. All right. So we're going to do one more. And this one's a little bit different. Okay, this problem reads, the order is received for gentamicin, 40 milligrams IV, Q6 hours for neonate. Available is gentamicin, 20 milligrams per 2 milliliters. How many milligrams will this neonate receive per day? Okay, so let's check our dosing schedule. The order is for Q6 hours. And the problem asks, how many milligrams will we receive per day? Right? So they don't match. So we just need to keep that in mind. But let's go ahead and start by doing our steps for this problem. Okay, so we're going to start with what we're looking for. The question says, how many milligrams will this neonate receive per day? So we're looking for milligrams per day. Okay, step 2 is to build our box. And in our box goes our order, which is 40 milligrams per dose. Now, do we need the 20 milligrams per 2 milliliters? That's the question. So this question isn't asking us anything to do with milliliters. It's not asking us what we're going to administer as far as a volume to this patient. It's simply asking how many milligrams will this patient receive in a 24-hour period. So we don't need this information right here. Okay, it's not pertinent to solving this problem. It's not necessary. Okay, so we're leaving it out. All we need is the 40 milligrams per dose. And then we're going to need a conversion to convert dose to day. All right, so let's plug in, starting with milligrams. We only have one thing in our box, so it can't be that difficult, right? So 40 milligrams per dose is in our box. We've used everything in our box. We can't cancel anything out because we only have one fraction in our problem. But we know we need to convert the dose to day, right? Because right now we have milligrams per dose. We need milligrams per day. So again, we're going to use one of those conversions. Q6 hours means that in 1 day, you're giving 4 doses. Okay? So I'm going to plug that into my problem, but I'm going to flip it and make sure the doses is on top again so I can cancel that out. Now I'm left with 40 milligrams, milligrams per day, which is what I'm looking for, or matches what I'm looking for. So I'm going to do my math straight across. 40 times 4 is 160. 1 times 1 is 1. Okay, so this answer is 160 milligrams per day. Okay. So let me show you really quickly, and then we'll be done and we'll take a break here. Let me just show you what will happen if you try to do this problem using the wrong information. Okay. So if you're looking for milligrams per day, which we've already determined, and you go to build your box and you say, okay, you just kind of get on autopilot and you put your order in there and you put your available medicine in there as well. Okay, so let's pretend you did that because you didn't, you just, like I said, went on autopilot, or you got confused and you weren't sure which one to put in there. Okay, so step 3, when we start plugging into our problem, you're already going to see a problem, right? Because you're looking for milligrams. So you're going to come up to your box to find milligrams. And the first thing you're going to see is you have two different choices there. So if you're doing your problem correctly, you will never have 2 different choices for what to plug into your problem first. Okay. So that's your first indicator that something's wrong. So let's say this happens to you and you still don't know what to do. You don't know which one's correct. Go ahead and try to solve it both ways and see what happens. Okay. We already know what happens if we plug in 40 milligrams per dose because we just solved it that way. So let's pretend you decide you're going to use the 20 milligrams over 2 milliliters. All right. So following our rules, the next part of our problem should have milliliters in the numerator, or the top, right? So when you look in your box, do you see milliliters anywhere? There's no milliliters in your box. Is there any conversion? Is there a conversion that's available from milliliters to days to dose? There's not. There's no such animal. Okay, so you're stuck. So the problem will tell you, don't force it. It's telling you right here, it's saying you can't go any further. There's not a conversion in your brain that will convert, because here's what you're looking for right here, right? And here's what you have. How are you going to convert milliliters to days? You can't. There is no conversion. So that's your indicator right there that something is wrong. Okay, so go ahead if you're not sure and try to work it out. And again, if you're following the rules, the problem will tell you, no, you're wrong, stop, because you can't continue. All right, so if this happens, then you just go ahead and plug the other one in and you should be able to solve the problem because we just did. Okay. All right, well, hopefully that was helpful, and we'll go ahead and stop for now and let you guys work on some problems, and then we'll pick back up with oral dosage problems.